And hello everyone, in this section we will learn the data types in the C language. And after this course, you will know and apply different data types for variables in your own C programs. And also, you will learn some common errors in the C programming and try to avoid making those mistakes. And in C programming, data types are declarations for the variables, and this determines the type and the size of data associated with the variables. Here is an example, and we have seen it before. And here, integer one is a variable of the int type, and the size of the int type is 4 bytes. And here is a table which showing the common user types in C programming, and the char, the int, the float, and the double are the basically data types. And the shoot, the num, and the assigned and signed usually indicate a large or a small number. And we will learn those concepts in detail. In particular, the numeric data types are arithmetic types, and they can be further classified into the integers and the floating point values. And first, we will introduce the char type, which is used for describing the character type variables. And the size of the character variables is 1 byte, which means it's 8 bits. And to get the exact size of a type or variable on a particular platform, you can use the size of the operators. And the expressions, the size of type, will get the storage size of the object or type in bytes. And we will use the size of function operators to double check the storage size of the type in the bytes later. And the char type is a character in C. And there are some examples showing the character types. And also, although this type is a character, however, the character is represented in memory as a binary numbers. Our computers can also recognize the binary numbers 0 and 1. And the value of the character stored in is determined by the ASCII code. The ASCII means the American Standard Code for the Information Interchanging. And the corresponding ASCII codes for some characters are listed here in this table. For example, the lowercase a corresponding to the ASCII code the 196, and the character 0 corresponding to the 48. And if we use the string format, the person sign C, we will get the character. And also, if we want to print it's an ASCII code of this character variables, then we can print using the string format and the percentage size and the D. And we will write a program and see the ASCII code for the characters to do the experiment. Next, let's see the int type. The int type is a standard integer, which usually be stored in 4 bytes in the memory. And due to the size of the 4 bytes, so it is limited by the size of the memory. use.
Could you help me and see the screen and the slides? Okay, let's continue.
For describing the character type variables, and the size of the character variables is 1 byte, which means it's 8 bits.
The ASCII code is American. Sorry. The ASCII code is the American standard code for the information interchange, and it will be used to such as for example, the ASCII code will be used to represent the characters. For example, if we use the characters, the chart type, then we will see the character for the program. However, if we use its ASCII code, we can get the number, its corresponding number of the characters in the program. And I will give an example later.
And to get the exact size of a type or variable on a particular platform, you can use the size of the operators. And the expressions, the size of type, will get the storage size of the object or type in bytes. And we will use the size of function operators to double check the storage size of the type in the bytes later. And the char type is a character in C. And there are some examples showing the character types. And also, although this type is a character, however, the character is represented in memory as a binary numbers. Our computers can also recognize the binary numbers 0 and 1. And the value of the character stored in is determined by the ASCII code. The ASCII means the American Standard Code for the Information Interchanging. And the corresponding ASCII codes for some characters are listed here in this table. For example, the lowercase a corresponding to the ASCII code the 196, and the character 0 corresponding to the 48. And if we use the string for the person sign C, we will get the character. And also, if we want to print its an ASCII code of this character variables, then we can print using the string format and the percentage size and the D.
Let's say example, we open our IDE, and in the first tutorial, the Pengfei have introduced the IDE, so you can also open your own IDEs and to type the code. Yes, the size of the type will return the bytes of this type will be used in the computer. And later we will use this size of functions to see the size of different characters, different data types. For example, the integer type. For example, for the char type, it will use 8 bits in the memory in our computer. We first write the comment of this code. And include the standard if we have a char such as C, such as A, and we print for it, using the percentage %C. And also we can print its ASCII code. Let's see the result. We may use the new line. We can see the character is A. However, its ASCII code is 96. We have known that the percentage sign D will represent the type of the int. However, we can print the int value of the char type. Its corresponding is ASCII code for this char type. Same as the A, we can also print other characters and to check the value of its ASCII code. So in this sentence, we print the int value of which is ASCII code of the char type C. Do you have any questions for this example? Yes, C is the name of a variable. For example, we can rename it as my char or something else. Same as the int type we have seen before, such as my int. This line means that we have a variable whose name is my int and its value is the 1. And also, this line has a similar definitions of the int type, which means that we have a variable whose name is my char and it's a char type and its value is uploaders A. Yes, same as the int type, which will tell us the data type of this variable. Yes, we have different data types in the C programming. Instead of the integers, we have the characters and also have some non-double and the float, the real number. We will see later. The compiler, in fact, the compiler can show the ASCII code of for its corresponding character. The ASCII code is a ruler to help is a ruler to encoding the different characters. So if we use the percent sign D, we can show this corresponding ASCII code. We cannot show the ASCII code for words because it will be a string type instead of a chart type. And we will learn the string type in the lecture in the future. They have only one character. Yes. If we use C, it's the self, the characters. If we use the D, we can show its ASCII code. Yes, they have the corresponding relationship between one characters and ASCII code. In fact, it has some rulers. You can remember some key ASCII code for the key characters, such as A. And you can see the ASCII code for the A is the 16.5, and for the B, it will be a 16.6. As showing on this, as showing the results is showing here. So you can remember some key ASCII code for some key characters, then you can know others. They following some rulers. Of course, if you do not remember the meaning of the percent sign C and the D, you cannot print the correct results, the message. For example, if we want you to print characters, however you print its ASCII code. Yes, this is necessary. If we do not use the sign, then it will be a specifier in the program. And this will be an error because we have not seen B before. Yeah, if we use this, then it will be a string. It's not a character. And we will learn the string in later or in the future lectures. This will bring the string. This is a character. If no more questions, we will continue.
And we will write a program and see the ASCII code for the characters. Let's do the experiment.
We have showing these examples.
Next,
Yes, because it's an integer, it's a number. This is the rules for the C programming. If we want to represent a char, we need to use this sign. If we just use to represent the number or integer, the value of the integer, we can just write the number here. If we also use this sign for the 1, then it will be a current instead of integer. So we should change this. So these two variables are different, and they are belongs to the different types.
See the int type. The int type is a standard integer, which usually be stored in 4 bytes in the memory. And due to the size of the 4 bytes, so it is limited by the size of the memory. And same as the char type and the integer type is also represented memories as binary numbers. And all our computers can also can only recognize the binary numbers. And integer can be the positive. Of course, the integer can be the positive or the negative, and its sign is determined by the first bit of the integers. The integers has 4 bytes, so it has 32 bits, and its sign is determined by the first bit of this integer. And if the first bit is a 0, which means that the integer is a positive number, and otherwise, if the first bit is a 1, and the integer is a negative numbers. And the range number of the integers variables is showing here. Later, we will show the ranges of different data types by programming. But now we just see the
because we have the 32, why the range is like this? Because we have the 32 bits to store those int type. So yes. Because it will take the 32 bits, and we will use the 1 bit for the sign. So we will have the 31 bits to store the value of the integer variable. Yes, but we have 0, remember? So this is 8 and this is 7.
And as introduced in the last section, we're using the string format, the %d to print the integers. And also the int type will use this a bit to define the positive or the negative sign. And the remaining the 41 bits are used to represent the exact number. And therefore, we can use the unsigned keyword to use all the 32 bits. And the unsigned int means that we only want the positive integers and ignore the negative ones. Next, we will introduce the real number types, the float and the double. the integers will not suitable for the real applications. And for example, if we need to calculate the areas of the cycle, or we want to calculate the average of the grants in this class.
The unsigned means that we will all the numbers will be the positive numbers. So this first bits of the signed number, the first bits will be used for the value instead of the sign. All the 32 bits will be used to represent the value of the integers because it's all the positive number.
So therefore, we need to use the real numbers. And the real number in C is similar to the scientific notations, and its storage areas will be divided into 3 parts. And the first part is 1 bit, which represents the sign, and the same as the integer types. If this binary number is 0, that means that it is a positive real number. Or if it's binary number is 1, then which means it's a negative real numbers. And the second part is the exponent. And for the float type, its exponent will use 8 bits, and for the double types, its exponent will use 11 bits. And the last part is matrices, that is the value. And for the float type, it will use 23 bits, and for the double type, it uses the 42 bits. And the format for the real numbers is showing here. And those 2 matrices and the exponents are choosing such that the formulate. And therefore, the float type will have the 11 digits of the positions, and the double will have the 15 digits of the positions. And same as the int types, we can also use the unsigned keyword or the sign to ignore the sign and use all the bits for the real times. And also, the print string format is the %sign if for the float types and the %sign LF for the double types. Of course, if we need to use a small number, we can use the type specifier should. If we need to use a large number, we can use the type specifier none. And the should and the none types are also the integers, and double and the float point values and their string formats are also showing here. We have another type is a void. We have no another we have known the point in the last section for the main functions, and the void type specifies that no value is available, and it is used in 3 keys of the situations. The function, the first situation is the function returns as a void. And there are various functions in C programming which do not return any values, or you can see that they return the void. In the section of the function, we will see some examples. And the functions with no return value has the return type as a void. And the second situation is that the function arguments as the void, which are the various functions in C which do not accept any parameters. For example, in the main functions, we use the void as the arguments as the main functions. And a function with no parameters can accept a void. And the last situation is point to the void, and a point of the type void will represent the address of our object, but not its type, and we will introduce the points later. Now let's write some program to check the size of the different data types.
We have talked about the size of function, and we can use the size of functions to check the size of different data types, and it will return the bytes. If we use the size of the type, then it will return the bytes of the type stored in the memory. First, we write a comment. This program is used for testing the size of the data type. So we write the size of data type. And we include the float. And we'll start the main function. Now we'll define some variables. First, it's a character type variable. It's another head, which is a float, where it will include some calculations in the float type for the it will include some calculations for the variables which belongs to the float type. Yeah, we have talk about the Studio IO point H. It's a header for the standard, the input and output library. Then we use the size of function. And also we can define an int type. Yeah, we can comment this line. If we use some float type, we can include this line for some calculations. But in this case, in this example, we can comment this line because we just need to print the size of the data types. Okay, we now define the shoot type. And we continue to define the non-type. Yes, because the size of this character of those different data types will be a large number. So we use the non-integer format to print those results. It's because the function the size of the return size of the data type, it is a large number. We do not print those characters or the variables. We print the size of the variables. So we use this format. Okay, we can run this program, run the code, and see that the size of the different data type. So the integers, it will use the 4 bytes. It will be the 62 bits. Do you have any questions for this function of the size of? Yes, we can use D here. In this program, the D is also okay because the largest number is 16. So we can use D. However, add the L here because the size of will return the unsigned type. If we use D, it will be an integer type. It will be a positive or negative value. If we use the LD, it will mean use the unsigned. If we use D here, it can still print the right results, but it's not the perfect solution. Because the function size of will return an unsigned integer. It will return unsigned non-integer. How many bytes? And 1 byte. will be 8 bits.
Also, we can write some programs to check the range of the variables in different data types.
We have seen the different size of the different data types. Now we can check the range for the different data types. So if you write a program, write a program, and you can choose the correct data type. We should include the limits. This header will include those variables, per defined variables and keywords for this for the range of the different data types. I just write some of them, maybe. Maybe it depends on your compiler. It will have some difference in different environment, but the standard version is something showing in this screen. You can double check the data type of the variables you defined. Usually it will be 8. So you can check whether you use the right variables and define the right data type for the variable. Yeah, the bit of the non-double in the last example is 16. Why don't we use the LF instead of the LD? Because the F means the float type, right? And it's for the real number. And this size of this function size of it will return the integer type instead of the real type. So we do not print the variable, we print the size of the variable. And the return of the size of the variable is an integer type. For examples, we just print those two data types, and we can see the range of those two different data types. If we use an unsigned int, we can see the unsigned int will have the will have almost the double range as the int type, because because all the numbers in the unsigned integers will be the positive number. Do you have any questions for this example? Unsigned. It means the unsigned int. And you can check the different format in the internet. They have the corresponding tables. And also I will show some part of the data types later. They are corresponding sign.
Here, the ranges of the different data types are summarized here. Depends on the different applications. We should choose the different data types for the variables. Here is some questions. We now have some review questions, and please state true or false for the first 5 questions and fill in the 3 parts for the float and the double data type.
You can type the true or the false on the chat box for those questions. Yes, some of you have already typed the answer in the chat box. Okay, most of you gave the right answers. And we see the answer.
Here is the result of these questions. As we know, the shoot will not take more memories than int, and int takes more memories than shoot. And the second situation is true. And the print fault for the child is the percentage sign C. And also the next question is true. And the three parts for the float and the doubles and the sign, which is the 1-bit binary numbers. And the second part is explosion, and the last part is a mantis. Now let's look at some different arrows in the C programming.
And we have seen those arrows in the first lecture, so we may skip it and continue our lectures to study the structured programming. Do you have any questions about the data types? And you can type on the screen, type on the chat box. And the next section, we will learn the structured programming. And we will learn some if else, and the switch, and the while statements. Now I will update the slides. Maybe we will have the 5 minutes and return. After the 5 minutes, we will learn the structured programming. Range is yeah, I include the float head is because where I want you to know that if you use some float calculations, you can include those head. But for this example, you can comment this line. So maybe we can continue. Do you have any other questions about the data type? So maybe we start the structured programming.
Hello, everyone, and welcome to the second lecture of the programming fundamentals. And same as the first lecture, to make sure the quality of the online course, I will mute your microphones. And if you have any questions, please type them in the chat box. And we will learn the structure of the programming in this lecture. And this is the learning objectives. If you after you are learning these lectures, you will know how to use the basic programming solving techniques and use the if selection statement and the if else selection statement to select actions from multiple different actions. And also use the while iteration statement to execute statements in a program repeatedly. And we will learn two types of the iterations. They are the counter control and the sentinel controlled iterations. And also we'll learn how the structured programming and using the increment and decrement and assignment operators. And before writing a program to solve a particular problem, we must have an understanding of the problem and also carefully planned solutions approaches. And usually we execute our plan step by step. For the example of the integers we learned at the last lectures. we will first read the first integers and then read the second integers. And then we will add those two integers and get the value, the total value of them, and then assign this value to the sum. And finally, we will print the sum. So next, we will discuss the technologies that can facilitate the development of the structured computer programs. And the structured computer programs is a programming method aimed at improving the clarity, quality, and the development time of a computer program, and by making some extension use of the structured control flow consistent of the selections and the repetitions block structures. Now we will introduce the concept of the algorithms, and the solutions to any computing program will involving executing a series of the actions in a specified order. And for the example of adding the two integers, we will execute the actions of the reading the integer 1, the integer 2, and then computing the sum, the total value of the two integers, and finally printing the sum step by step. And this produced for solving a problem in terms of the actions to be executed and the order in which those actions are to be executed is called the algorithm. And correctly specifying the order in which the actions are to be executed is very important. Consider the rise and the shine algorithms followed by one general executive for getting out of the bed and going to work. And there are 6 steps for he or she will do. First, get out of the bed and take off the pajamas and take a shower and get dressed and eat breakfast and finally carpool to work. And this order will get the executive to work well prepared to make the critical decisions. And also suppose that the same steps are performed in a slightly different order. We changed the order for the third and the fourth steps. And this steps will be following that, will be like that. Get out of the bed, take off the pajamas, and get dressed, take a shower, and eat breakfast. Finally, couple to work. And in this case, our junior executive will show up for work, working with. And specifying the order in which statements are to be executed in a computer program is called the program control. And this program control is very important to execute a plan in a right order. We have known the algorithms, but how to represent algorithms and writing the pseudocode is a useful way. The pseudocode is similar to everyday English. It is convenient and user-friendly, although it is not actually computer programming language. And the pseudocode is not actually programming language, so it cannot be compiled into an executable program. It will use the short terms or the simple language syntax to write code for a program before it is actually converted into a specified programming language. And the pseudocode programs will help you think of the program before writing it in a programming language like C. And pseudocode consists of the characters, so you can conveniently type the pseudocode programs into a computer and using the editor program. And a carefully prepared the pseudocode program can be converted easily to a corresponding C program. We now give some common rules of the pseudocodes. The pseudocode will consist only of the action and the decision statement, and those that are executed when the program has been converted from the pseudocode to C and is run in C. And the definitions are not executable statements, and they are the simply messages to the compilers. For example, the definition int I tells the compilers that the type of the variable I and instruct the compilers to receive the space in memory for these variables. But this definition does not cause any actions, such as input, output, and calculations on or comparisons to occur when the program is executed. And some programmers will choose to list each variables and briefly mention in the purpose of each at the beginning of the pseudocode program. And this is a pseudocode for the program for the problem of the adding the two integers. And first, it will tell us we should input the two integers, and then we should calculate the sum of those two integers. Finally, we print the sum. And later, we will see some complex examples for the pseudocode and for more complex problem. Another way to help develop the algorithms is the flowchart. Like the pseudocode, the flowchart is useful for developing and representing the algorithms, although the pseudocode is preferred by most of the programmers. And the flowchart is a graphical representations of the algorithms or of the partial of the algorithms. And the flowchart is driving use some special purpose symbols such as the rectangles and the diamonds, the rounded rectangles, and some small cycles. And those symbols are connected by the flow lines. And consider the flow chart for the sequence structures. We'll use the rectangles symbol, also known as the action symbol, to indicate any types of the actions, including calculations or input and output the operation. And the flow lines in the figure indicate the order in which the actions are performed. First, the grade is added to the total, and then the 1 is added to the counter. And the C language allows us to have as many actions as we want in a sequence structure. When driving a flow chart that represents completed algorithms around the rectangle symbol containing the word begin is the first symbol used in the flow chart, and every symbol containing the word end is another symbol used. And when driving only a partial of the algorithms, the rounded rectangle symbols are replaced by using the small cycle, small cycle symbols that also called the connector symbols. And perhaps the most important flowcharting symbols is the diamond symbols, also called the decision symbol, which will indicate that a decision is to be made. And we will see these decision symbols and the examples later. Normally, the statements in a program are executed one after the other in the order in which they are written. And this is called the sequential execution. And for the example of the integer addition program, we will execute those statements one by one. And first read the definition, the two variables, and read the first print to enter the first integers, and then we will input the first and read the first integers. And as same as the first integers, we'll read input and read the second integers. And then we will add the total value of those two integers, and finally print for the sum of those two integers. And however, various C statements we will soon discuss enable you to specify that the next statement to be executed may be other than the next one in the sequence. And this is called the transfer of the control. And the research has demonstrated that all the programs can be written in terms of only three control structures, namely the sequence structure, the selection structure, and the iteration structures. The sequence structure is simple, and unless the directed, otherwise the computer executed the C statement one after the other in the order in which they are written. And the last example of the flow chart we have seen is the sequence structure. And the executable C statement either performs the actions such as calculations or input or output of the data, or makes decisions. And we will soon see several examples of those. For example, we may make a decision in a program, and in addition to the sequence structure, we may need to make decisions in a program. For example, to determine whether a person's grade on an examiner is greater than or equal to the 16, and whether the program should print the messages, "Congratulations, you passed." And we need to, in order to achieve this decision making, we will have some.
And for the examples about the selection structure and the iteration structures, we will introduce them later. And we will give more details for these two structures.
Complex of this decision making. First, we need to check the conditions. For example, we need to check is the distance between the point U to the Canadian town will more than the point U to the center. And then we will perform the tasks based on the decisions, such as if the point U to center is shorter, then I will drive to the center instead of the Canadian town. Otherwise, if the Canadian town is more close than the point U, I will drive to the Canadian town. So, how to implement this decision making? This selection statement will help us. The C provides the three types of the selection structures in the forms of the statement. First, the if statement. The if statement either performs actions if a condition is true, or skips the actions if the condition is false. And also the if-else select statements will perform actions if a condition is true, and performs different actions if the condition is false. And also the switch selection statement, we will discuss it in the next lectures, which will perform one of the many different actions depending on the value of the expressions based on their characters. And if statement, they can only perform one actions if the condition is true. So it is also called the single selections. And the if-else statement will perform actions if the condition is true. Also, it will perform different actions if the condition is false. So it also called the double selections, because whether the true or false, it will take actions. So it called it the double selections. And finally, the switch statements will also be called the multiple selections, because it will perform one of the many different actions depending on the conditions. We will give an example to help to understand the if and the if-else statements in the schedule code. And suppose we want to know whether a student passed a course or the passing grade on an examination is 16. And so the future code statement of the if statement is if the student's grade is greater than or equal to the 16, then we'll print the passed. And which determines that whether the condition the student's grade is greater than or equal to 16 is true or false. If the condition is true, then passed is printed. And if the next partial code statement in the order is performed. And if the condition is false, the printing is ignored, and the next partial code statement in order is performed. And also, let's see the if-else statement. The if-else statement or selection statement will allow you to specify the different actions to be performed when the condition is true and when it's false. For example, the pseudocode statement: if a student's grade is greater than or equal to 16, print the pass, else will print the failed, which prints the pass if the student's grade is not greater than the or equal to 16, and will not pass if the student's grade is less than 16. And in either case, after printing printing statements, the next partial code statement in the sequence is performed, and the body of the else is also the indented. This is a flow chart for the selection statement for the if selection and the if else the statement. And the decision sample has the two flow lines emerging from it. And one will indicate the directions to take when the expressions in the sample is true, and the other the directions to take when the expressions is false. And the decisions can be based on the conditions containing the relational or equally operations. And in fact, a decision can be based on any expressions. If the expression evaluates to 0, then it's treated as false. And if it evaluates to non-zero, it's treated as true. And we will introduce it later. And the flow chart of this if-else statement shows that the flow of the control in the if-else statement. Once again, besides the small cycles and the arrows, the other symbols in the flow chart are the rectangles of for the actions and the diamonds for decisions. If the conditions is true, it will take actions here, and if the conditions is false, then it will take another actions. And the corresponding statement may be written in C as these two partial code. Notice that the C code corresponds closely to the pseudocode. Of course, you will also need to decline the int variables grade before. It is just
the flow chart is a technique help us to write the C programming, to write the C code. So if you have the problem, you may first write the flow chart, and then you can write its corresponding C language based on your flow chart. It's a technology for you help us to develop the programming.
A partial of the code, and which is corresponding to the selection statement. And notice that such the space is optional, but is highly recommended as it helps to enhance the structures of the structured program. And the C compilers will ignore the white space when saying at the last lecture the characters such as the blankets, the tables, and the new lines used for the space and the spacing. And also the if-else statement may be written in C as this, and we will see the examples later.
We now type those two statements in our IDE and see the results. Suppose we have a variable which is an integer type. For example, we have the 16. Then if it is larger than will print all. And we can see the results. Okay, it shows the past. If we change the grade as 15, then there will be there's nothing will be showing in the screen because it did not print anything. If we add the else statement using the else statement, then we can get the result. It will not pass this examination. So the two statements are different. The if statement is just a single statement. If the condition is true, then the body of the if statement will be executed. And the if else is a double selection, the double selection statement. If the condition is true, it will include some statement. And if the condition is false, it will also doing some actions. Do you have any questions for this if and if else statement for this simple exam? And later we will see some complex exams for the if and if else statements. Now we introduce the if statement. The if statement depends on the actions of the if statement. It depends on the conditions. If the condition is true, and the statement in the body of the if statement will be executed. Or otherwise, if the condition is false, then the body of the statement is not executed. And whether the body of the statement is executed or not, or after the if statement compiles, the execution process with the next statement after the if statement will be executed. And the conditions in if statements are formed by using the equality operators or the relational operators. And we will introduce those two types of operators later. Okay, this is the examples for the if statement. Could you guess the if the integer 1 is 3, if the integer 2 is 5, could you print the answer on the chat box for this program, for this code? I also typed this code to the IDE. We will read the first integer and read the second one. The 3 and the 4 for those two integers, the 3 and the 5 for those two integers, respectively. Yeah. Thanks for your reminding. So if the integer 1 is a 3 and the 2 is a 5, what's the result? You mean there is nothing in the screen? We will print nothing. Yes, the result will be well done. We can see. Then I input the 3 and the 5. We can see that well done is printed. So remember, the statement besides the if statement, behind the if statement, it will be executed, no matter this line inside the if statement is executed or not. If we remove this brace to here, what's the result? Yes, we will get nothing because no any strings, no any messages is printed. Also, maybe we can try this. If the integer 1 is 5 and the integer 2 is 3, it will not be an error. It just print nothing in the screen. So in this in the last example, we do not print anything. We print nothing. Yes, in this case, we will print these 2 messages. So remember, this line is always be executed, no matter if the conditions in the if statement is true or false.
And we have known the if statement and have seen the conditions. In fact, the conditions in the statements are formed by using the equality operators and the relational operators. Here we summarize some those operators, and the first 4 rows are the relational operators, and the last 2 rows are the equality operators. And the most left side, the corners, is the operators we use in the mathematics. And this line is the third line, the third column is the examples of the C conditions. And the first, the operators is a greater than. and the second is less than, and the third is greater than or equal to. We use the two sign, the great sign and the equal sign to represent the greater than or equal to. Note that there is no brace between those, there is no space between those two signs. Also, we use the same methods to represent the less than and or the equal to. And the next two, those are the equality operators. We have used the one equality sign to represent the assignment operators. Remember, we assign the total value of the two integers to the variables sum. So we use the two the sign, the two equal sign, the double sign to represent the equal to. Also, we use this sign before the equal to represent the not equal, and this sign will represent the not, the meaning of the not. When using multiple, we have using the one if selection statement. We can also use the multiple if selection statements. Here is the examples. The if statement compares the values of the variables of the sum 1 and 2 to test for the equalities. If the conditions are true in one or all or more of the if statements, the corresponding body statement displays appropriate lines of the text, and the space between the body of each if statement and placing the blank lines above and below each if statement will enhance the program readability.
And we also type this exams in the IDE and see that we can use the multiple if statements in a program. And if the conditions in multiple statements are true, then those bodies of this of those if statement will be executed. We also have two numbers. And we read the two numbers. We can use the two number and at the same time use the one statement like this. And if the number 1 is equal to number 2, remember we will use a double equal sign to represent the equal to. Because we have used something like that, we have used the equal sign to represent the assignment. Not equal to. And this is small. Great. Okay, we have type this code, and now we will run it. And then we will input the first and the second number. For example, if the first number is 3 and the second is 5, and it will show that those because those three statements are the conditions of those three if statement is true are true. For example, it will show that 3 is not equal to 5, and 3 is this to 5, and 3 is this or equal to it is an error because 3 yes, it's true because 3 is this or equal to 5. And you can see that those three conditions are true for those if statements. So it will print three messages. And it was noted that we cannot increase a space into those two signs. It will be an error. We must write those two signs without any space. We use the scaffold to read those two numbers. Because I type the 3 and the I type the 3 and the 5 for this program. For example, maybe we can write please. And we can see the we should include. Okay, then I type it. And also you can see some branching line here. We use these lines for the readability. If you have no more questions about the multiple if statements, we may continue.
And this figure lists from the highest to lowest the precedence of the operators introduced in the last slides. And the operators are showing top to bottom in decreasing order of the precedence. And the equal sign is also operators, and we highlighted it here. All those operators with exclude the assignment operators associated from the left to the right, and the assignment operator, those equal sign, which is associated from the right to left, and refers to the operator precedence, the chart, which when writing the expressions containing many operators, and confirm that the operators in the expressions are applied in the right order. If you are unsure, you can not sure about the order of the evaluations in a complex expressions, using the brace, the parentheses to group those expressions or to break the statement into several simple statements. Also, be sure to observe that some of these operators, such as the assignment operators, which is associated from the right to left rather than from the left to right. Now we will see an example how to apply this equal assignment. The equal assign the assignment operators to switch the two values of the variables.
So in these examples, we will show how to switch the two integers, the two variables, the value of the two variables using the assignment operator. Also, we will read two numbers. And we print 4. After read those two numbers, we can print 4, the value. Now we will sweep the values of those two variables. Just use the assignment operator. We need another variables to be intermediate steps to stories. Yes, the assignment operators calculate from right to left. Yes, for example, if the assignment like this, or like this. First, we will calculate the right part of the expressions, and then assign the value of the right part to the left part. For example, if we have two numbers, the number 1 and the number 2, so we can write something like this, which means that we should assign 5 to the number 2, and then assign the value of the number 2 to the number 1. So the number 1 and the number 2, the values of the number 1 and the number 2 will be the 5. Both are 5. And we can run this program. If we and the 3 and the 5, yeah, maybe I using the sign help for the readability. We can see that the two. We can see it before we sweep the values of the two variables. The values for the two variables are the 3 and 5 respectively. After we sweep the values of the two variables, then we can see the values of them are the 5 and 3 respectively. We only use the assignment operators to implement the sweep for two variables, the values for the two variables. Do you have any questions for this assignment operator? First, we will define the new variables, and this new variables will have the original value of the number 1. And then we can assign the number 2's value to the number 1. And finally, we use the original value of the number 1 to assign the value to the number 2. Do you have any questions for the three statements and how it works? If the number one is 3 and it is 5, so after this statement, the tempo will be the 3, and the number one will still 3, right? And after we perform the actions for this statement, then the tempo will still the 3, and the number one will be the 5. And here we will get the value of the number 2 from this new variable. So if you have any, we normally will use those sweep operators, those sweep methods in our C programming usually, and you will use it in many cases.
We first type this program in our IDE. Now it's your time. You can giving this questions. You can develop algorithms to solve this this problem, and the requirement is to develop algorithms to find a number is odd or even, and you should write schedule code to check if a number is odd or the even, and also write a C code that takes an integer as input from the use and print out whether it is an even number. And I may give you 10 minutes to doing this exercise, and then we will solve this problem together.
Now you can try to solve this problem by yourself and first write a schedule code, and then try to write the C code corresponding to the schedule code. After you finish it, you can type on the chat box, tell me that you have finished it. Then we will solve this problem together and see how can we solve a program using the standard language step by step. Yes, you are right. You can use this you can use the if statement and also use the integer division and the integer remainder operators. And at the first lectures, Pengfei has introduced the IDEs and how to run a program in an IDE. So this time you can try it on your own machines, on your own desktop. You can also use other operators, as long as you can solve this problem. I see that Ying has finished this task, and you can type some values to see whether the your program is correct. Maybe we give the 1 minute more because we still have lot of the content should be learned in this lecture. But we only have the 15 minutes. Okay, the Hui is also finished. Maybe we back to the lecture, and I will quietly to talk about this problem. The pseudocode is something will maybe like this. Maybe first we'll input an integer, and then we will use the selection statement. If the integer is even, then we'll print the even, and if the integer is not, then we'll print the odd. And in the its corresponding C language is something like this. First, we will define int type. We will define an integer variable who is int type, and then we will read the value for this variable. But how can we judge if the value is even? So if it is divided by the 2 is 0. We can use different operators. Sorry, I use I should use this. Yes, I should use a reminder, or I can do something like that. If right. Now we can test the program. Can test our code. We should use the new lines for readability of the results. So these two measures we used can get the correct answer. So which one do you choose to use in your own program? Yes, the first one is a simple case. Do you know why the second one is also a work for this problem? Why integer divided by 2 and then the multiple 2 will not equal to the value itself? Yes, the value of the integers will be the fractional part of the fractional. This will be the integer division, and the fractional part of this results will be ignored. So these two cannot be equal. Okay, great. We can continue for more. Next, we will learn the nested if-else statement.
We have seen simple examples of the if-else statement, and we can list the if-else statement.
Yes, if this variable integer is a double type, then this will be equal. These two will be equal. Because the integer division, so it may have different results for the two expressions.
To test for multiple cases by placing the if-else statement inside the if-else statement. And for example, the following pseudocode statement will print A for the examination for exam grades greater than or equal to 16 or to 19, and B for grades greater than or equal to the 19, but it less than the 18, or but it less than the 19. And the C for grades, which is greater than or equal to the 17, but less than the 19. And the D for the grades will greater than or equal to the 16, but less than the 17. And the F for all the other grades. And this schedule code may be written in C as this forms. And if the variables grade is greater than or equal to 19, all four conditions will be true. But only the puts statement after the first test will be executed. After that, the puts is executed, the else part of the outer, the if-else statement will be skipped. And we can type this code to our IDE and test the results. Also, the puts is other types of the print functions. It will print the characters inside this to start in the screen, but it cannot using the defined format as the print4 functions. As far as the C compilers is concerned, we can have the another version of this listed if-else statement, and this both forms are equal. And the later forms is popular because it avoids the deep indentations of the code to the right. And the if selection statement exports only one statement in its body. And if you have only one statement in the if body, you do not need to enclose it in the braces. To include the several statements in the body of the if statement, you must enclose the seat of the statement in the brace between the left brace and the right brace, and the seat of the statements contained with a pair of the braces is called a compound statement or a block. And in this case, if the grade is less than the 16, the program will execute both the puts the statements in the body of the else and also prints you must take this course again. So it will print those two statements, those two strings on the screen. And the process of storing the two statements in the else are important. Without them, the statement of the you must take this course again will be outside the body of the else part of the if and would execute it regardless of whether the grade was less than the 16. And we will see the examples. We type these examples in the C program and test the results.
Due to the time limitation, so we do not type this example to the in the IDEs. We will continue our content.
Also, the C provides the conditional operators, which is closely related to the if-else statement. And the conditional operators is C's only ternary operator. It takes the three operands, and those together with the conditional operators forms the conditional expressions. And the first operand is the conditions. The second one is the value for the conditional expressions if the condition is true, and the expressions is the value of the whole conditional expressions if the conditions is false. And for example, the put statement will contain as its second argument a conditional expressions that evaluate to the string the past if the condition great or equal to 16 is true, and to the string the field if the conditional is false. The put statement performs in essential the same way as preceding the if-else statement. And the second and the third operands in conditional expressions can also be actions to be executed, and the conditional expressions is read. If the grade is greater than or equal to 16, then put the past, and otherwise put the field. This is true is comparable to the preceding the if-else statement. We will see that the conditional operators can be used in some places where the if-else statements cannot, and these examples will be showing in the future courses. We add two new operators in the operator table, the AND and the OR operators. The double signs means and which connects the multiple conditions. If its left condition is true and the right condition is true, then it will be true. And if one of the two conditions is false, then it will be false. And the OR operator is similar to the AND operator. If one of the two conditions is true, and then it will be true. And if both conditions are false, and then it will be false. For example, the AND operators. If x larger than 1 and meanwhile x is less than the 10, then this conditions will be true. If one of those conditions is false, then the whole conditions will be false. In fact, a condition can be based on any expressions, not only based on the true or false. If the expressions evaluates to 0, then it will be treated as false. And if it evaluates to the non-zero, it will treat it as the true. And this is an example giving the x, y, and z. They are the 3, 4, and 2 respectively. And you can get the value of those conditions. You can first try to calculate the value of the expressions, and then you can further get the true or false result of this condition. Now maybe we give you 3 minutes, and you can type your answer on the chat box.
So for these expressions, you can test whether this expression is true or false. Maybe 1 minute. You may type your answer on the chat box. And remember, the sign means the OR operator. Yes, the answer is true. So remember, if the expression is if the value of the expression is to 0, it will be false, and if it is non-zero, it will be true.
Okay, then there are four another examples. The English conditions of the four examples are given, and please write the C condition statement for the four examples.
So please write the say conditional statements based on the English condition. I have seen that one has put his answer, he or she's answers, and you may double check your answers. For example, the she, yeah, thank you. So you can compare your answer for the second question and the third question. You use the and for the to connect two expressions. However, in the second, your second answer, you use or to connect two variables or one expressions and a variable. Yeah, so the first answer, the first question maybe can also be revised to this form.
The results for the four examples are shown here. First, if x not greater than z and the y will greater than z, then it will be true. And the second, if x is equal to the 1 and the x is equal to the 3. And the third example is that if the z x is in the range of z to y, so x should greater than z and x should less than the y. And we can add the not sign outside the last conditions. We can get the result of x is outside of the range z to y. So this sign means the not. If the conditions in the brace is true and the not sign, it will be false. And if the conditions in this inside the brace will be the false, then outside this sign and this not, sign, it will be the true. We have learned the decision making, which means the condition if, and if else statement. Now we will learn a iteration statement that allows us to specify that action is to be repeated while some conditions remain true. And the schedule code statement, while there are some items on my shopping list, then I will buy the next item and cross it off my list. This schedule code describes the iteration that appears during a shopping trip, and the condition. There are more items on my shopping list. Shopping list may be the true or the false. And if it is true, then the action buy the next item and cross it off my list is performed. And this action will be performed repeatedly while the condition remains true. And the statement contains in the while iteration statement consistent the body of the while. And the while statement body may be a single statement or a compound statement. And finally, the condition will become false when the last item on the shopping list has been bought and crossed off the list. And at this point, the iteration will stop, and the first schedule code statement after the iteration structure is executed. And as an example of the while statement, consider a program segment which designed to find the first power of the 3 larger than the 100. Suppose that the integer value variables produced has been initialized to the 3. And when the following while iteration statement finish executing, the product will contain the answer, and the flow chart of the figure shows the flow of the control in the whole iteration statement. When the while statement is entered, the value of the product is 3, and the value product is repeatedly multiplied by the 3, and taking on the values, the 9, the 26, and the 91, and the 81, and the successfully. And when produced becomes the 243, the condition in the while statement, which produce will less than or equal to 100 will become false. So this will stop the iterations, and the final value of the produce is 2043, and the program execution continues with the next statement after the while iteration. Now we type this code in our IDE and see the process of this while iteration.
We may skip this exam in this coding exam because due to the time limitations, and you can try this example by yourself.
Counter-controlled iterations, and this technique uses variables called a counter to specify the number of times a set of statements should be executed. And the counter-controlled iteration is often called the definite iteration because the number of the iterations is known before the loop begins executing. And to show how the algorithms are developed, we will solve several versions of the class average problem. And consider the following problem statement. A class of 10 students, they take quiz, and the grades the integers in the range from the 0 to the 100 for this quiz are available to you, and the determiner usually to determine the class averages on this quiz. And the class average is equal to the sum of the grades divided by the number of the students. And the algorithms for solving this problem on a computer must input each of the grades, perform the average calculations, and print the results. Let's say the pseudocode to list the actions to execute and specify the order in which those actions should execute. In these examples, the iteration stops when the counter largest than greater than the 10, and we show how the pseudocode algorithms are development. The algorithms mentioned a total and a counter, and a total is a variable used to accumulate the sum of the values, and the counter is a variable used to count, and in this case to count the number of the grades entered, and then it will int the while interactions, and each time it will input the grade, and then add the grade into the value of the total, and meanwhile add the 1 to the grade counter, which means that we have count the this grade for this person, and after the grade counter is greater than 10, then we will leave this while. We will stop this while iterations, and finally we will calculate the average by the total divided by the 10, and finally we can print the class average. This is the C code for the corresponds to the pseudocode of for the problem of the class average problem, and we first type this code in IDE and execute it. Now we go.
I will not execute this code this time, but you can first go through this code, and then I will give some comments for some important parts for this code. For example, first we define the unsigned int type for unsigned variable the counter, and then we define the 3 int type variables. They are grade, total, and average. And then we will assign the total be the 0, because before entering the while iterations, the value of the total should be 0. It will be used to accumulate the total value of the grades, and then the counter will be 1, or it can be the 0. Or it can be a 0. It depends on yourself. And now, while the counter is less than 10, then we should print into the grade, and we read the grade. And then we calculate the total. We add the total by the value of the grade, and also count 1 into the counter. And then after we have counted 10 grades, we can stop this while iteration and calculate the average of this and then calculate the average of the total grades. Finally, we print the value of the average.
Go through this code again and explain some parts of some important statements of this code stored in the total's memory locations. We cannot guarantee the value of the total is 0 if we do not assign the 0 to the total. And the count values are normally initialized to 0 or 1, depending on their use. We will see the difference of them, and later
So if the counter is a 0, we assign the counter as a 0 at the beginning. Then this sign should not be the less than or equal to. It should be the less than only if we set the value of the count as 0 at the beginning. So these two versions are both correct.
Initial value will consist of garbage value, and the value not stored in the memory locations reserved for that value. So if a counter or total isn't initialized, the results of your program will probably be incorrect. And then this is the while statement, block. First, if the count is less or equal to 10, we can enter the grade. We can ask the user to enter grade. Then we read the grade from the user, and then we will add the total, the grade at this time to the total, and also add the run to the counter, which will count the number we have read for the grade. And next, we will the average calculations in a program produced, and then we will divide it by the 10 to get the value of the average. Finally, we print this value. And in these cases, the average calculations in a program produced integer result of the 81. Actually, the sum of the grades in this example is 81.6, which when divided by 10, usually is 81.6, which is a number with a point. And we will see how to deal with such numbers, and which we have learned this number, the foreign point numbers, in the next section.
Do you have any questions for this example? Yeah, the percentage is means the string. Do you have any questions for this example? It's counter-controlled iteration. It is one of the most commonly used iterations in C programming. If no questions, we will continue.
Let's generalize the cross-averaging problem and consider the following problems. Develop a cross-averaging problem that will process an arbitrary number of grades each time the program is run. And in the first class average examples, the number of the grades 10 was known in advance. And in this example, the program must process an arbitrary number of grades. How can the program determine when to stop the input of the grades? And how will it know when to calculate and print the class average? And one way to solve this problem is use a special value called a century value, also called a sign value, and dummy value, and or a flag value to indicate the end of the data entry. And the user types in grades until all the grades has been entered. The user then types the flag value to indicate the last grade has been entered. And this control iterations is often called the indefinite iterations because the number of the iterations isn't known before the loop begins executing. And because the grades on a quiz are normally non-negative integers, and so the -1 is an accepted value for this problem. Since a run of the class average problem might be processed a string of the inputs such as the 94, the 96, the 74, and the 70, and the 98, and then finally will input the -1. The program would then compute and print the class average for the grades. And the pseudocode statement initially total statement initially total to 0 and initialize the counter to. This is the C code. The program corresponds to the pseudocode we have seen at the last slide, and we will first type this code in our IDE and then explain some important parts in this code. It was noted that in the while loop, here from the 9 in a while loop here, these are necessary to ensure that all the 4 statements execute within the loop, and without the braces, the last 3 statements from the 9th, from line 26 to the line 30, the last 3 statements in the body of the loop would be outside of the loop, which will lead to causing the computer to interpret this code incorrectly as follows. And this would cause an infinity loop if the -1 is not input as the first grade. We can see, we can type this new situations in the C IDEs and see whether this loop will not stop. This is also an important part in our code. And we have seen this statement in our code. We add a float in front of the total. But why we need to add this float?
Can you follow this content, or you think it is a slow? It is a little quick. Then for the counter controlled iterations, do you have any questions? Yes. Maybe now for this part we may learn this part next time. But for the controlled iterations, do you understand or still cannot follow? Okay. So the content for the while interaction, do you understand the while interaction? Yes, know how the while and the counter works. So you noticed from this controlled iteration, right? Okay, maybe you can try the IDE and try the examples in your own code after this lecture. And then if you have any questions, you can post the questions on the MS Teams, and I will tell you the solutions and explain those questions in the next lecture. So maybe we continue or stop here and then tell this control iterations in the next lecture. You prefer to continue the slides to play the video and the slides, or stop here? Okay, at this time we will stop here, and you can see see the recordings for the counter controlled iterations, and I will also explain the counter controlled iteration in the next lecture. So in next lecture we will start from the counter controlled iteration. And in the future courses, maybe I will not type every program in the IDE because we do not have enough time. But at the beginning, I think we should type the program in the IDE to help you have some basic understanding and for this C programming. So maybe we stop here today. Because we do not finish the content in this lecture, so the assignment about the first two lectures will be given at the end of the next lecture. No, because the assignment one include some content about the controlled iteration.